looks a lot longer, but we'll see if I can finish this in 10 minutes. An aircraft lands on a runway. Its velocity v meters per second and time t seconds after landing is given by the equation 50 plus 50 times e to the negative 0.5 t, where t is between 0 and 4. Find the velocity of the aircraft when it lands and t equals 4. So those are two different questions. When it lands, the velocity, you're starting the time after it lands, so that's asking for v when t is 0. So 50 plus 50 times e to the 0, which should be 100 meters per second. Okay, and when t is 4, you just plug in 4 for t. You get 50 plus 50 e to the negative 2. And if you plug this in the calculator, you get about 56.767 meters per second. Okay, write down an integral which represents the distance traveled in the first 4 seconds. Okay, so the integral for the first 4 seconds, and I know this is always positive, so I don't have to put absolute value signs, but you can. So here's 0 to 4, 50 plus 50 e to the negative 0.5 t dt. Maybe you should put brackets around that. And that would be the integral for the distance traveled. In this case, that'll be the same as displacement because you're always moving in a positive direction. Okay. Yeah, think about it. It's an airplane landing, so it's not going to change directions. C, calculate the distance traveled for the first 4 seconds. Ooh, okay. Let's do that down here. Okay. So, what was it? Part C? We want to actually calculate this 50 plus 50 e to the negative 0.5 t. Negative 0.5 t dt. Okay, so first find the antiderivative, which would be 50t, and then 50, and then you have to divide by this, so negative 100 e to the negative 0.5 t, and then you're going to evaluate that from 0 to 4. And if you plug that in, you get 200 minus 100 times e to the negative 2 minus 0 minus 100, because e to the 0 is just that's a 0, e to the 0 is 1, so there's that. So it would be about 300 minus 100 e to the negative 2. And if you plug that in the calculator, 300 minus 100 e to the negative 2, it's about 286.466. 286.466 meters. That's how far the airplane traveled in the first 4 seconds. Oh, let's go back down. Okay, keep forgetting to write 3 significant figures. That would be about 286 meters. There. Okay, what's next? D. Okay, sketch the velocity against time. Well, hold on, what's going on? After 4 seconds, the aircraft slows down at a constant rate and comes to rest at t equals 11. Sketch the graph of velocity against time from 0 to 11. Clearly label the axes and mark on the graph the point where t is 4. Okay. Let's go back and remember some important information. At 0, when it lands, 100 meters per second. At 4 seconds, you're at 56.7, 56.8 meters per second for 3 sig fig. Okay, so if you remember those things, D, I'll use a different color and do it here. D. Okay. So let's say that's 50, and that's about 100. And there is the velocity, and here is time. So let's put 11 here, 4 there, and 0. Okay, so at first you were here. Okay, and at 4 seconds you're at 56 point something, so right there. And from at 11 seconds you're at rest. So over here you are actually going in a straight line there, and from here to here you would do something okay, something like that. Yeah, good enough. Okay. What's next? Part E. Find the constant rate. Okay, well, do we do anything else for the graph? Sketch a graph of velocity against time from a clear axis and mark in the graph where the point t is. Okay, I think I did that. That's when the t is equal to 4, and the velocity was 56.8-ish, and yeah. All right, next. The question is, find the constant rate at which the aircraft is slowing down between 4 and 11 seconds. Well, so that's not too bad. So that's, you're asking for the slope of this straight line. So how did the y value change? It went from 56.767 and you went to 0, and that happened from 11 to 4 seconds. 11 minus 4. So 56.767 over 7. That would be about 8.11. 8.11, but the unit is, because this is a velocity graph and you're looking at the slope of the velocity, that's going to be kind of like a derivative of velocity, so meters per second squared. There. Next, F. Okay. What is the... Okay, calculate the distance traveled by the aircraft between 4 and 11. Now, you might be tempted here, maybe, to set up an integral from 4 to 11, but you don't know the function. It's a straight line, so you can figure that out. But why would you? You can easily just find the area of the under the curve, because you know that's the integral. So that's this right triangle here. So the distance traveled from 4 to 11 is going to be 1/2 times 11 minus 4, which is 7, times the height of the triangle is 56.767, which is about 198.684. 198.685. You can round up to 3 significant figures, 199 meters. There you go.